Hello there and welcome. I'm an old guy who does maths, and today we're going to look at the gradients for linear equations and how we find them. Okay, so the general equation of a linear equation is written like this: y is equal to mx plus c. This is what we're looking for. M is the gradient. I don't know why it's called m. Let's not get into that. But the number that is beside the x, m, is the gradient of the line that this equation would generate. So to look at a real equation, the 2 here is the gradient. M gradient 2. To look at some other examples, y equals negative 3x minus 7. The negative 3 here beside the x is the gradient. The gradient is negative 3. Here we've got a fractional gradient. Don't be intimidated by fractions. It's often better to leave these as fractions rather than convert them to decimals. The gradient of this line is 2 over 3, 2/3, but I'd usually say 2 over 3. And what you'll notice about all of these is that they are the number beside the x. They're not this number, which we'll deal with in another video. So the gradient of this, m, is equal to 2 over 3. Now, how do we calculate that if we don't have the equation, but we've just got a line? The gradient is generally said to be the rise over the run. What does that mean? Well, if we have a convenient line here on our Cartesian plane and an equation here that says that the gradient is 3 over 2, we should expect the following: that if we run 2 units across this way, run, and rise 3 units this way, we should form a triangle with this line. And so the rise here is 3. This is not to scale. The rise here is 3, and the run here is 2. So the rise over the run is 3 over 2, which is what the gradient of this line is. Now, because it's a straight line, you can do this anywhere. So down here, you would get the same result. The rise is 3, the run is 2, the gradient of the line is 3 over 2. And I'll just explain this number here very briefly. This is the y-intercept. You can see it there. Okay, but that's something for another video. Okay, so where do we move to from here? Well, we can do all this algebraically. And very often, because numbers are inconvenient things, this turns out to be the easier way to do it, even though formulas such as this might look intimidating. Essentially, what this is it's a restatement of what we just did, but it's restated in algebra. So I'll do this, I'll work through this, and hopefully it will become clear how this works. So first of all, a formula tells you to do something. So my advice to people when confronted with a formula is just do what it says. Okay, so in order to do what this says, we need to label our coordinates. We'll label 3 as x2, not x squared, but x2, and we'll label 4 as y2, and negative 2 as x1, and negative 4 as y1. Now, when I set this up, I had no idea what the gradient of this thing would be, other than that it would be positive, because that is a positive gradient. If it were negative, it would look something like that, or like that, or like that. Okay, so we've got these coordinates labeled. So what we do is we just stick them one at a time into the formula. So we have to take y2, which is 4, and we put it there, as the formula says. Now, from that, we subtract y1. y1 is negative 4, so we subtract negative 4, which means that because these two signs are the same, it's the equivalent of adding. So we get 4 plus 4, which gives us this, and gives us 8 as the numerator of what is going to be a fraction. Then we find x2, which is up here, 3, and we put it there, just where it says in the formula, 3. And that formula instructs us to subtract x1. Now x1 is already negative, so just like up here, we are subtracting a negative. We have two negatives, they make a positive. So what we've got is we've got 4 plus 4 over 3 plus 2, 8 over 5. That is our gradient. That is this formula in action. So the equation of this line is 8 over 5x, because the gradient sits beside that. And although it's not specifically covered in this video, we did have a y-intercept here, and I'm assuming that I put it in the correct place, but I haven't checked. But just for the sake of completeness, we'll say that this is where the y-intercept is at 0, 1, and that's where it goes in the equation. But fundamentally, today, we're interested in what goes on here and how we calculate it. Thank you very much for watching. See you again soon. Bye-bye.